y'all, welcome to another beautiful day, a beautiful lesson in Precalculus. So we're going to be looking over the ideas with angles depending on the quadrant, and then radians versus degrees. So just a few things that I want you to be aware of as you're looking at these problems. So first, we have here on my whiteboard, I have a X and a Y coordinate plane just kind of drawn, sketched out randomly here. So I want you to keep in mind that as you move around this plane, let's say we're following the path of the unit circle around. So I'm trying to freehand this so it looks crazy. But ideally, the unit circle should be the exact same radius all the way around the circle. So as you're moving around that, I want you to be aware of, first, we split this into 4 quadrants. This is our quadrant 1. This is quadrant 2. This is quadrant 3. And then this is quadrant 4. So it's a counterclockwise rotation. In this first quadrant, the angles that are represented in the unit circle are between 0 and 90 degrees. So let's call our angle theta. Okay. Or in radians, it's between 0 and pi over 2. Okay. So if you have an angle anywhere here, that it must be between 0 and 90 degrees. If they give you any other angle, then they shouldn't give you any other angle in this first quadrant. It's rather they'll give you some other angle when you're working on the problems from this vector section. In the second quadrant here, remember this makes a 90-degree angle. The X and the Y axes are perpendicular. So this is the 90 degrees. That's where I'm getting the 0 all the way to 90 degrees here. Then once you cross over into the second quadrant here, all your angles are greater than or equal to 90 degrees, but less than 180 degrees, right? So this is another 90 degrees, so 90 plus another 90, this will give you 180 along the x-axis here. So in radians, that will be between pi over 2 and pi. So if you get an angle here and it's not between 90 and 180, that means they're giving you what we call a reference angle. So that means that you have to figure out that in relation to the quadrant that you're in. So for example, if they give you some vector here and they tell you that the angle here is, I don't know, 60 degrees. First, you need to be aware that, okay, they're telling me this is 60 degrees. So this can't possibly be the full angle from the vertical here all the way to this point. It's only the angle between our y, or this pi over 2, 90 degree point here, and our terminal side here. So that's just the distance from there to there. But if you want to know the full angle from the vertical all the way over, so if you wanted to know all of this, let's call that theta, then you would have to take this 60 degrees and add 90 degrees, because from the vertical here, I'm sorry, the horizontal, I keep saying vertical, from the horizontal here, I would have to go all the way around to get to the 90 degrees. And then I would have to go that additional 60 degrees to get to the vector here, whatever this vector is. Let's call it vector V. So that means I have to remember to take 90 plus 60 to get this actual angle here. So 90 plus 60 equals 150 degrees. So this 150 degrees is what I would use if I was trying to find the coordinates of the vector, if I was trying to find the, I think that's pretty much all you need it for. If you're not given the coordinates, you would use this as your theta to find the coordinates of a given vector, okay? So this is assuming they give you the magnitude, let's say they give you the magnitude, then this will be the angle you use in order to find the components, okay? Alright, similarly, they can also give you, let me erase a little bit here. Excuse my hair is shedding. Then they can also say they give you the same vector, but they say that this angle here is, for example, 25 degrees. So again, you should need to notice, okay, wait, 25 degrees, that doesn't make sense because it's in the second quadrant. So that means they're only telling you what's the angle between the horizontal here and the vector. So that's only the angle between these two. But in order for you to find the components, to find that theta all the way around the circle, remember that you have to find all this up to this point, okay? So one thing we can do here, on the other hand, is, well, if we're going all the way to the horizontal, that's 180 degrees. Well, since they gave us this sliver here of 25 degrees, then we can do 180 minus 25 degrees to get the angle that we would use for the component, or our theta. So our theta here would be 180 minus 25, that's 155. Okay. So I just wanted you to see an example of, you have to be careful that you're paying attention to the angle that they give you, because sometimes they're giving you a reference angle and sometimes they're giving you the full angle from the horizontal here, our starting point, all the way to the vector. So you have to be very careful about what's happening in each quadrant. Just to finish this off, in this third quadrant here, it's between 180 degrees and 270 degrees, or pi and 3 pi over 2. And then in the fourth quadrant, the theta is between 360 degrees and 270 degrees. And then the radians would be 3 pi over 2 and 2 pi. And because one thing, if we remember how we go about the coordinates here, so this is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1. So this kind of goes in a way where we consider this 270 degrees. We kind of use that within that quadrant as well. So I guess we wouldn't technically consider the 270 degrees the 270 degrees or the 180 degrees in any particular quadrant, but let's just say we're going to use 270 degrees or greater than will be in that first quadrant, because technically they have kind of completely separate let me make sure I say this. What's happening specifically at these places along the axes, it behaves slightly differently than anywhere else. So we only really consider in the quadrant what's not there. So I kind of want to only use, let me go back. I only want to use the equal to it as the smallest part of that particular interval. So I use 0 here because it's considered part of the first quadrant. 90 here is a part of the first quadrant, so we use that underline. 180 is a part of this third quadrant, we use that, and then 270 would be a part of this fourth quadrant, so we use that as well. Yeah. So in terms of data that you need to use the component, this is how you think of it. If they give you an angle that doesn't match what should be in that quadrant, that means they're giving you some type of reference angle. So you have to think logically about, okay, well, the full side here will be this, so I need to subtract this in some way to get the actual theta. So just be careful about that. Most of the errors that I saw in the vector unit exam were in relation to this in some way. One last quick thing also, because you don't have graphing calculators, a lot of you are using a different, are having to use a different thing to transition from degrees and radians and calculate with degrees and radians. So just a reminder, you can go to geogebra.com, so I have it spelled here in the thing, and type enter. You're going to click start graphing. So I'm just waiting for it to load. So it gives us a little message here. Extend this a little bit. In order to do something, I don't really care about that. Okay. So here we can type in something. So let's just say I'm just making up a problem. You want to calculate 15 cosine of 45. Or let's just do an even one, cosine of 0. So it's using 15 cosine of 0, and it gives you 15 as the answer. Let's say we want to find 15. Let's say, let me think of a good one. 15 sine of 60 degrees. So you have to remember, is it giving, or you have to think about rather, is it giving you the correct angle for sine of 60 degrees? Well, if we're looking at the unit circle, the sine of 60 degrees should give you a different result. So let's just do sine of 60 degrees. It keeps giving you 1. So this means that there's something going on in this, and it's not giving you the correct either radians or degrees. So you have to be aware of that. So in order to get that correctly here, there's a window that you can open here that allows you to go through trig. So you can find the mathematical functions section here to open it up, and you can go to cosine, and then you can type in the 60 degrees. And if it's in degrees, it'll give you the little open circle in the top right corner. So you know that, okay, I'm in degrees now, and I'm correctly evaluating this in degrees. You can also change this to radians as well. So let me extend. So if I open this back up, let me see if I can figure out how to. Alright, so I paused the video for a second because I was looking up if you can change it to radians. So I don't see the option here. So everything you want to assume that it's being put in degrees. So you're going to have to find the conversion if you're in radians to degrees if you want to use this GeoGebra calculator.